All right, guys. Today we're going to start a very short lesson for this week before we start our review for finals. Okay, this is called the features of polynomial graphs. So if we were to draw graphs of all the polynomial functions that we've been working with, we'd end up with graphs that look like this. Okay, so check this out. So basically, it goes forever in both directions, right? Either up or down. And there's a lot of loops, or not loops, I should say, but there's a lot of ups and downs in between for some of these, okay? So that's what we're going to be going over today, how to identify parts of the graph and characteristics of the graph, okay? Or in other words, features of these graphs. Okay, so the first thing we want to talk about is the degree of the graph. Okay, now the degree, remember, refers to the exponent or the largest exponent in a polynomial. Okay, so we have two types, either odd or even. It's pretty simple. The degree is either going to be odd or even, and that's it. Okay, so how can you tell if the graph has an odd degree or an even degree? Well, it's very simple. Okay, let's take a look at these two examples here. Here I have an odd degree polynomial, f of x equals x plus 1. Okay, so the degree here is 1. Okay, because of all the variables that I have here, the highest exponent is the 1, or the largest exponent is 1. Of here I only have one variable, x squared, right? And so this is then the highest degree, 2. Okay, so notice this is even and this is odd right here. So when it's odd, notice here that the left is going down and the right is going up. Okay, so we have one going down and one going up. When it's even, notice both ends are going up. Okay, now what if it was, let's say for example, f of x equals negative x plus 1. Okay, well, you're still going to end up with the same type of behavior, except this one's going down from left to right. But notice here, this is still going to be, one of them is going down and the other one is going up. So the characteristic here of the degree, right, can be found on the graph by just looking at the ends of the graph. If the ends are going in opposite directions, then we say the degree is odd. If the graph ends are going in the same direction, then we say that the degree is even. So for example, let's do another even one right here, and I'll just make this like this. Okay, I just made up all these curves here, but notice here the ends are what tell us what type of degree it is. Okay, so if both ends are going in the same direction, whether down or up, then the degree is even. Okay, if here, let me draw another example with a lot of waves here. I'll just go like this. Okay, notice here I have a lot of curves going on in between, but that doesn't matter. This is what matters here. Okay, the ends. So if one end is going down and the other one's going up, okay, or if one is going up and the other one is going down, in other words, opposite directions, then we say odd. If they're going in the same direction, then it's even. So let me go ahead and write this right here. Opposite means odd degree, and then same means even degree. Simple as that. Okay, let's move on. Now we get into the sign of the leading coefficient. Okay, so if we have a graph here, okay, we're either going to have a positive or a negative leading coefficient. Okay, now what is a leading coefficient? Well, for example, let's say I have f of x equals x squared plus 3x plus 5. Okay, Again, the degree here would be the 2, and then that would be my leading term there, okay? So my leading coefficients, whatever sign that this term is, if it's positive, well, then it's considered a positive. If it's negative, it would look like this. It would just have a negative in front of it. So let me just rewrite this whole thing, but with a negative at the start. So notice here, this is considered a negative leading coefficient, okay? Okay, so that's what it looks like in polynomial form, but what does it look like in a graph? Very simple also, okay? Let me show you guys. It basically goes like this. If it's positive, okay, then it's gonna go up on the right. So it doesn't matter what happens on the left. If it's positive, it's gonna go up on the right. So for example, x squared, right? X squared, that's even. We just finished talking about even degrees right here. When it's even, they're going in the same direction. Let me write this right here, same direction. This is opposite direction. Okay? So remember, when it's odd, one's going down, one's going up. Okay? It could be either end, and I'll tell you guys how to know right now. If it's even, they're both going in the same direction. So watch this. If I have a positive leading coefficient, then it's going to go up on the right. So say for example I have x squared, and then ignore all this, don't even worry about that. This means that it's even because it's a 2 and it's positive. That means it's going to go up, so it's going to look like this. Okay, notice even means they're both going in the same direction, but positive means that this side is going up. Okay, so that's positive. But notice I can have an odd degree and still be positive. So say for example I have f of x equals x to the third power plus blah 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 right here. It doesn't matter what else comes after this. If we have this situation, okay, that means that on the right side, because it's positive, it's going to go up like this. Okay, but since it's odd, that means this side's going to go down. So I can make it look like this. It's going to go up, it's going to have a hoop, it's going to change direction, and it's going to come up like that. So you see, both of these are going up on the right, so that makes it a positive leading coefficient. Okay, notice how this is odd and this is even. So I can have odd positive and even positive. For positive, it just means it goes up on the right. So positive means it goes up on the right. Okay? Positive means it goes up on the right. Well, guess what negative means? Negative means it goes down on the right. So negative means it goes down on the right. So we're just talking about the right side here, okay? So the sign tells us what happens on the right side of the graph. Okay, so let's do some examples here. So a negative one here, for example, this is negative x squared. Forget about this right here. We're just going to graph the right side here. So we know that it's even, so they're both going to be going in the same direction. But since this is negative, it's going to go down on the right. So I just need to make sure that this side goes down because it's even. Okay, so it could look like a letter M. You see that? Both ends are going down. And it's going down because of the negative here, okay? And also because it's even. What if I had a f of x equals negative x to the third plus whatever, right? So, again, we are only interested in on the right side of this. Since it's negative, it's going to go down on the right. Again, I wrote it right here. Negative means it goes down on the right. So this tells us it's going to go down on the right, okay? But since it's odd, that means the other side is going in the opposite direction, right? So we just went over that on this one here. If it's odd, that means they're going on in different directions. So this is going to look like this. Okay? And we'll get to other details of how many curves a graph can have. okay, at a later video. Now, the next part here, how many real zeros? Now, when we talk about real, we mean non-imaginary. How do we determine how many real zeros there are? We don't want to know exactly what the zeros are, we just want to know how many of them are there. So here's what I like to do, okay? To find the real zeros, you just go along the x-axis and see how many times the graph crosses the x-axis. That's it. Okay, so here's what I'm going to do. Look, for the first one, I'm going to start on the left-hand side and I'm going to go across the graph. And every time I hit the graph, I'm just going to go ahead and circle it there. At that point, I have one real zero. It crosses again. That's another real zero. And then right here, it crosses a third time. That's another real zero. And there's no more crossings. Okay, so I have 1, 2, 3 real zeros. It's as simple as that. Okay, so let's do this one. Let's start from the left and go all the way to the right side until we count all the real zeros here. Okay, so again, there's one real zero there. We go across. That doesn't count right there. That's not part of the curve. Remember, this is going like this. It's like a W, and then it crosses again right there. So this has 2 real zeros. That's it. Okay. Let's keep going here. Let's go here. Notice here we're going to go across like this. I see one time that it crosses there. Go across. There's another time, and then one more time right there. So this also has 3 real zeros. Okay. Notice here I go across, and this curve here, this graph is hovering above the x-axis. It never crosses the x-axis. So this has no real zeros. Has none. That means all the zeros here are imaginary. Okay? Let's move on here. This one has several. Take a look here. So here it crosses here. That is considered one real zero. Notice here this one touches the x-axis, but it does not cross. Well, that still counts as a real zero. Okay, keep going. There's another location where it just touches it. It does not cross, but it still counts as a real zero. Here one that crosses, here's another one that crosses, and here's one more that crosses, and that's it. Then it goes up forever and it never comes back down. So we have 1, 2, 3, 4, 5, 6 real zeros. Okay, and the last one here, notice it only crosses once, and then right here these are all under it, so we don't have any other crossings, so this would be considered just a 1 real zero. Okay, now remember, it doesn't have to cross, it could just touch it, and that counts. Okay, so these two just touched, but it counts as a real zero. Okay, all right, and lastly, okay, now these are considered maximum or minimum values. Now, as the name suggests, maximum should indicate that it's a point that is high. Okay, a minimum indicates a point that is low. Okay, so when we're talking about maximum and minimum values, we're talking about wherever the turns take place. Okay, so notice here we have we're going up here, up as we travel from left to right. We're going up, and then it's kind of like a roller coaster. We're at the highest peak right there, and then we start coming down. So that would be considered a maximum. Okay, as we go down the roller coaster. Then notice here we reach the lowest point, and then we change directions. We turn and we go up. So it's considered a minimum value. Okay, so what if I only want to know about maximum values? Well, basically those are all the mountaintops. Okay, the mountaintops are our maximum values. So this one has 2 maximum values. Okay, how many minimum values does this have? Well, those would be my my dips right here at the bottom. So that would be considered just a minimum value. Let's look at this one here. We have our mountain peaks. That would be here and here. So those would be considered maximum values. And then here we have our dips there. Okay. And we would call those minimum values. Okay, so I have 4 total values there. This one here, I only have 1 mountain peak, so that would be my only value, my maximum value. And that's it, okay?